My name is Jaime Limon. I'm a senior planner with the City of Santa Barbara, and I'm the design review supervisor. And I was charged by my manager, Betty, to come up with a training program for our city boards and commissioners this year. And we selected this topic because we were getting a lot of questions in the previous years actually, about these topics. And I thought it was timely to try to get some education to our boards, members and commissioners on these issues. And with the recent fire that have brought forward development proposals, rebuild proposals, we are getting more questions about pre-built homes, modular manufactured homes, and I thought it was also a good topic to bring forward. This training is being taped, so maybe that's the reason some of our board members have not arrived for this training. They have been informed that this training tape will be available to them. So I am thankful for those of you that did arrive. I think we have a good program today. I think it's going to be informative. I would like to have you possibly save your questions till the end of each session. We'll have a question and answer period for the experts to answer any questions you may have. We do have a sign-up sheet that we'd like to have everybody sign up just to tell us who attended today's sessions. We have handouts for each session, and each speaker has an informative program, I think, that will bring forward some interesting questions that you might have about these issues. Why are we dealing with this issue? We do have an actual sustainable design element as part of our submittal requirements. And we have Heather Baker that's going to be participating in a later session that will talk about our green program and our requirements and what we're thinking about considering to try to improve that type of requirements that we apply to single-family residential development primarily. I do want to thank the presenters that have taken the time. They're volunteering their own time to come in and try to share this information with us, and we do appreciate it. The last thing is I do want to thank primarily my staff here, Michelle Bedard and Heather Baker, who helped organize the seminar, and hopefully, again, it'll pay off with additional insight on this topic for future board members as well. So with that, I'd like to have Heather, I guess, introduce. She's going to start the first introductions, I guess. Do you want to do? Oh, okay. First introduction is Dennis Allen, who will come forward and make a presentation hopefully, on pre-built construction. Yeah, just on the side here.
Good morning. I want to share something very briefly with you that's unrelated to the topic this morning, but I found very exciting. I live right at the epicenter of the Jesucita fire, right up at the upper end of Tunnel Road, and many of our neighbors were burned out. We were partially burned, but fortunate that way. But yesterday I noticed we have a lot of beautiful oak trees, as much of the canyon is covered with oak trees, and there's all kinds of new little pink buds coming out of the oak trees. And the arborist told us that it's going to be a year to 2 years before we see any life in the oak trees. Ours are totally brown leaves. They said it's going to take even longer if the leaf canopy was left on them than if they were bare. But there's all this new life just popping up all over the place, and it's so exciting to see how nature just comes back, and fast. So it's anyway, even among all the ashes, there's great things happening. We're going to be looking at basically factory-built structures and homes this morning. I don't profess to be an expert in this area. There's certain areas where I have quite a bit of experience, but other areas almost none. So Karen's helped me. Karen Feeney from our office has helped a lot on pulling some of this information together, and I think it'll give a more complete picture of how well she's done on this. This to the mouse, okay. Nope. Always fun with electronics. There we go. So I thought it'd be good to start with some definitions because there's a lot of confusion around the terminology. Manufactured homes basically are entirely built in the factory. They're turnkey homes. They're controlled entirely by the federal government, by the Housing and Urban Development Department of the federal government. And they control all aspects of those homes. The HUD standards were set up in 1976, and prior to that, these were basically known as mobile homes. So this is just a slightly more regulated version of mobile homes. Is that one? Oh, let's see, I better keep going here. Modular are the homes that we've probably seen more of in Santa Barbara. They're also entirely factory built. The modular homes are regulated state by state and with some local jurisdiction regulation. They're also, both of these are transported on our highways, so there's certain rigorous requirements structurally that relate to those. But the manufactured are federally controlled. The modular are state controlled. The next level of factory built is panelized, and it's not an entirely factory built home, but it's a partially built. They're components that are built in the factory, and then they're shipped and assembled on site, and there is much more local jurisdictional control related to the panelized home. And then there's kind of a continuum between panelized and pre-cut. Pre-cut are primarily site built, but there are many of the components that are factory determined. Most of the kit homes that you've heard about would be what would fall into this pre-cut category. There's been a lot of talk really over the last 40 years about factory-built structures. So usually they're called manufactured structures, manufactured homes. And there's always been a lot of promise. This is the wave of the future. This is what we're going to be seeing. They're going to be cheaper. They're going to be better quality. They're going to be faster built. And we've been hearing this. I've been hearing this for 40-some years. And the promise has never really been realized. There's sort of a new wave of this interest and promise that's appearing now. And the thing that I think there really is potential in this, and I will try to share some of that potential. Most of the systems that we're still seeing, with the exception of the manufactured homes, the modulars and the panelized are not fully realizing the potential that this promise sort of holds out there. But I think as systems are perfected, and of course the electronic elements that have been added to these systems, I think hold the potential to really realize the cost savings and the speed that has been held out there. So manufactured home, this is one company, American Home Sales. As you can see there, these are quite attractive. There are a number of other companies, and I've just picked a few of these. There's well over 50 companies in the country that make manufactured homes. It's been the biggest success element of factory-built homes, and these are a few of the companies that make them in the West. Here's a few more. As you can see, the Clayton home even has a two-story manufactured home. Silvercrest is the more typical kind of thing. What is frequently referred to as double wide is closer to that. That probably is a double wide. And that's a kind of that's probably the most frequently built manufactured home is the double wide. But some of them get in a little more customization. The permitting issues, as I said before, it's all federally mandated. Local jurisdictions have to accept the federal codes when a manufactured home is installed in their jurisdiction. The only input that the local inspections can have relate to the site issues and the foundations for these structures. They do deliver and speed. As you can see there, many of them make the claim. Some of them it takes longer than others depending on the site. But from the time of order, they can often deliver one of these within a few weeks' time. So they're very fast. The limiting factor is often what's required on site rather than what happens in the factory. The limiting factors on design, one of the big ones is what they allow, what the federal government allows on the highways. And the 13.5 feet wide and 60 feet long is the maximum size that's allowed for these. Plus, you're allowed a 15-inch overhang in addition to that 13.5 feet. Most of these are built with I-beams in the understructure to give them the strength while they're being moved on the highways. And then they can be assembled in several components. They are basically move-in homes. So if somebody needs a home rapidly, this is a very viable option. These are the ones that were typically down in the Katrina area that were in the news a lot for a number of reasons, a number of stories related to them. You can find all kinds of stylistic options on these, but very, very minimal choices really on floor plans. Because they are transported, they all have raised foundation systems so that there's always a minimum of 18 inches of crawl space underneath them. Greenness, this is something that interests the city of Santa Barbara and interests our company very closely. And most of these companies do not do a good job on adding environmentally friendly aspects to them, good energy efficiency. Now, I qualify that by saying that as a result of what happened in Katrina, where there was a lot of health issues, the federal government has stepped in and they now are requiring only insulation that is very low in formaldehyde. There were stories about people getting sick in those the manufactured homes down there, a number of stories, so that the federal government has upped the standard in terms of controlling the amount of formaldehyde that can be used in the manufactured homes. They also, for the same reason, are limiting the volatile organic compounds that can be in the finished products, the paints, the glues, et cetera, that are used in these structures. Some of them are Energy Star rated, not a federal requirement for all of them, however. And some of them are paying attention to using cementitious siding, which from our point of view here in Santa Barbara is one of the better exterior skin materials for high fire areas, for wildfire areas. And some of them pay attention to water, not all of them do. Most of them do not. But what happens with most of these, when they do add the green elements, they charge a significant additional premium to the cost element, which is one of the real pluses for these types of homes. And the reason they do that is they have very much a formula for assembly line production of these. And anytime they deviate from that, it really throws them into a tizzy. It's not easy for them to make those adjustments, and so as a result, they charge a significant upcharge. The cost of these, as you can see, this is one of the real pluses and one of the reasons this type of manufactured, of factory-built homes has been very successful is the cost. Typically, the structure itself is between about $45 and $65 a square foot. That compares with, site-built custom homes here in Santa Barbara that start about $300 a square foot and go up from there. That $300 is a very tight, relatively modest figure for a custom home here in Santa Barbara. When you add in the site, the permitting, the transportation and so forth, that figure basically doubles. So typically you're hearing, if you buy one of the packaged plans for one of these homes, you're typically in the $100 to $120 range. I know of some of them that have been in different parts of the county that pretty much the cost factor is right in there. If you customize them, you're jumping up into a much higher per square foot cost, $150 and on up. The advantages, really, of manufactured homes is you can get quality. Now, one part of the quality that is pretty uniformly delivered is the structural. They are well made because they have to, the federal standards require that they be really more rigid and more engineered than site-built homes because they have to be transported with all that movement through our roads and highways. So structurally, they do deliver. On many of the other things and the selection of the interior finish and so forth, the quality is quite mixed, and so that's an area to be very careful on. They are a great choice for affordable housing, especially if you can get one of the companies that pays a little more attention to the indoor air quality and the health issues of them. The HUD regulations do address energy efficiency, and so they don't come close to the Title 24 standards we have in California, but they do meet the base standards for energy efficiency in the country. And they do address the issue of accessibility. They are fast on delivery. That's one. Those two things they deliver really well on: cost and speed. Greenness and quality, they don't do so well on. The floor plans are not flexible, so these are more the disadvantages I wanted to just kind of share with you from my thinking about these. They're not appropriate for sloped lots, so a lot of the consideration in the high fire areas where we just had burns, many of those are steep sites, and these would be not appropriate for those kinds of situations. We talked about the greening, very limited local review, and that's a big issue for Santa Barbara. So most of these are not appropriate for most spots in the county and in the city of Santa Barbara, certainly in the city here. Modular homes. Modular homes are a real step up in both cost and quality. Here's a couple of the companies that we know about. Living Homes has had a lot of attention down in the LA area, especially Santa Monica. I think that was where their first home was built. Marmol Ratzinger has also received a lot of attention, and most recently we've been hearing about Hanta homes. They're the most cost-effective, the ones that we've encountered. They're produced out of Northern California, and that's one that's being now installed in the county at the Sedgwick Nature Reserve. Here's another company that does modular housing, Michelle Kaufman. Their offices are in the Bay Area. Their factory's up in southern Washington. This is one that was permitted on Pedregosa Street between Garden and Santa Barbara Streets. All of these houses, even more than the manufactured, they tend to be transported in box components. That's an interior shot of that particular house. This just shows where these are located and how many of houses these companies have produced. Most of these are still ramping up, getting their systems down. The Hanta one has the longest track record so far. But in terms of permitting, this is a little different issue than the manufactured homes in that the local jurisdiction has more control. Any design review requirements for housing in a local area apply to these houses. So these do have to go before the ABR review or the historic landmarks, depending on where they are. The overall permitting and quality control is at the state level for modular homes. The state does issue the permits for these, and the state does have inspectors that go to the factories where these are built and maintains the quality control that the state requires. So it's not just where they're made, but it's where they're installed. The state where it's installed has to sign off on it, whether they're produced and manufactured in the state or not. Basically, modular homes come with all the finishes inside. They have all of the tile, the floor, the drywall, usually the the paint is put on, the cabinets, light fixtures, appliances, everything is shipped in the modules. The one that we saw a blow up in the front, in the top one, is kind of a hybrid. It had 4 boxes that were shipped, picked up by cranes and set on the site, but the center section where you see that row of horizontal lights, that was, the roof was part of the factory-built component of that, but the rest was all site-built. So it had some parts that were site-built and some parts that were produced in the factory. Once the home is installed on the site, then there's additional kind of finishing work that's required and just making everything fit. The part that the local jurisdiction has full control over is all the site stuff, the foundation, the utilities, drainage, so all the civil engineering components. The limiting factor can still be that you're combining something that's made relatively rapidly in a factory with what happens on site. So getting those two to mesh has been an issue for many of the companies. Again, the constraint is what's allowed on the highways. And it's 13.5 feet wide by 60 feet long. That's the maximum, about 800 square feet. Many of the modules are smaller than that. You can exceed the width, the 13.5 feet of width, if you produce the parade moving down the road with a pilot car at the front and the rear of the structure. You've probably seen that on some of our highways. And then the local jurisdiction also has to write off on what they allow on their roads. But typically, the 13.5 feet wide is allowed on all roads in most areas. The design elements of most of the modular housing is contemporary. You don't see many with pitched roofs. You don't see many that look like traditional houses. Contemporary seems to be the wave, and there's a certain ease of fabrication that determine that. There's a number of possibilities on floor plans, and as I say, you could take and put these boxes together in any combination. So it's pretty easy to do 2 or even 2.5, 3-story structures by how you combine these boxes. We worked some on one down in Ventura in the Keys. Involved 13 boxes, 13 modules. It was over 4,000 square feet. So you have a lot of flexibility, but it's all within the constraints of what you could do with boxes. These structures, and maybe it's because many of these companies are newer companies, have been much more interested in and trying to accommodate the green things. They achieve success in this to varying degrees. The living homes, the one that there have been just a few built down in the LA area, they've achieved silver LEED status in terms of green. The Breeze House, which was the model that was on Pedregosa from Michel Kaufman, it turned out that house on Pedregosa is very green, but their base package for the Breeze House is good on energy efficiency, and it has a number of elements in it that are green, but a lot of the green elements are upgrades on it. They set it up so that it's pretty easy to put solar photovoltaics on the house, and that one on Pedregosa has those. Another model that's done by Michel Kaufman is called the Lotus House, and its base package is super green. Some of the things that they include in that, they have a green living roof, which I guess you're going to be spending quite a bit of time talking about today. But that's a standard on their base structure. They make that house, in terms of electrical use of the house, 100% provided by the panels on the roof. They pay a lot of attention to rain and groundwater handling. They have a gray water system that feeds back through the toilet flushing in the house. Again, it's a standard component of that house design. They also pay attention to the materials on the exterior. Usually they're fiber cement, but not always. Fiber cement is a product that we pay a lot of attention to here in high fire areas because basically it's a non-combustible material. The wall assemblies are made out of SIP, structural insulated panels, on that particular house, and where the floor and the roof system are not out of SIPs, they use an open cell foam insulation, which is a very good foam, a very good insulating product. They use on-demand water heaters, which are very efficient. They have a super efficient heating and air conditioning system, air conditioning being a part of that only where it's needed depending on the site. And they use high-performance doors and windows, exterior doors and windows. Their time frame stretches out. You see how this compares with the manufactured, which was often 2 to 3 weeks, maybe at the most a month and a half. Here we're getting up into something that's 46 weeks and 54 weeks, so right around a year. And as you can see, I won't go through all the pieces of this, but what's interesting is this is very typical of what we find with custom homes, where the permitting process and the engineering and the design part take as long, if not a little longer, than the actual manufacturing and the production of the home. And we're pretty close on that on both of these. Actually, on the custom home, they're having the design development and engineering 15 weeks and the permitting 8 weeks. So they're almost up to 6 months for that process. And then the fabrication is about 4 months. And that's close to what we see in doing site-built custom homes. Costs for these range pretty much from about $225 a square foot up to $400, and you get into the customs, you can go up to $700 to $800 a square foot. In terms of cost, these are not less expensive than site-built homes, with a few exceptions. If you stick to a standardized design, you can bring the cost down a little bit below what a custom cost would be, and you can speed it up a little bit. The design costs add on top of these basically production costs. So the thing that we experienced on the Pedregosa house was that a custom site-built house would have been right about the same cost. Could have been even a little less. These are a whole different product and quality-wise than the manufactured houses we've been talking about. So as I said, you can cut time and cut costs a little bit if you stick to one of the pre-designed packages. You have considerable leeway on customizing, and the experience that we've encountered, and I think most of the modular home people, is everybody wants to customize it a little bit. And of course that shifts you out of at least one of the advantages of both speed and some dollar savings. The local jurisdiction gets good review on these, not complete, but they have a part of it. And in Santa Barbara, where it has to go before the architectural review, you can move a window around. You can change the way they stack. You have authority to be able to make those changes and additions. Of course, that often, again, changes the cost and the timelines on them. One of the real pluses for this kind of thing is you cut way down on waste by building it in the factory. Often these homes will have just a couple trash cans, big trash cans full of waste at the end of the whole process through the factory. With paying attention to resources used in housing, that's a real plus. I give them kudos on that element of it. And as we've been saying, construction time can be reduced. The potential plus on construction time is that you can be doing the site stuff at the same time that the house is being built in the factory. So typically on a site-built process, everything has to be sequentially, chronologically. So you can double up during that period if the planning and the production schedules are set up properly. Some of the the difficult aspects or the things to be aware of that don't go so well with modular homes is that there's always a local contractor involved. And the local contractor usually takes care of the site stuff. And many of these companies do a very good job of communicating with their clients and in making decisions. They have well-structured processes, but they often don't do very well in coordinating and working with the local contractor. So that can produce glitches and issues. Some of the issues relate to the warranty issues. Most of these companies are far away from where the product ends up, and to get them to travel that distance for a little thing. What we found on the Pedregosa, that we ended up doing a lot of the warranty things that weren't really in our jurisdiction, and then we had to wrestle with the company, the modular company, to try to get compensation. I mean, we set that up and got there okay ahead of time, but it was a cumbersome process where that often leads to dissatisfaction on the part of the clients, of course. Even though there's more review with this than manufactured housing, it's still limited review. There's not as much control as a site-built home. The designs, as I said, are mostly contemporary. That could be a plus for some people, but it also can be a disadvantage. You really don't find traditional homes in the modular category. It's very, very tough to. It's the cost advantages are not great. It's very close to be what a stick frame is, and sometimes it's higher. The panelized or pre-cut examples, as I say, these are really two different things, but there's a continuum between them, so we're going to kind of look at them together. What we're starting to see, and this applies to custom-built homes, is we're starting to see engineered pre-cut packaged components of houses. The eye-level floor system, I don't know if you're familiar with that, but it's all worked out, computerized in Hayward Lumber, for example, does it. And what arrives at the site is the whole floor system, all the pieces cut to length. It's all labeled, it's all packaged, so the builder just undoes it, and it's basically like assembling something with Tinker Toys. It goes very fast. There's no waste because it's all computerized. Every stick of wood is worked out on the computer so that the maximum wood and usage can be made out of that piece of wood. So again, waste is cut way down. The structural insulated panels, like you see in the upper right, that's another very great system to use for a pre-cut. You submit plans, and the critical element there is to make sure that the shop drawings are double and triple checked, because once a factory cuts it, you lose all the advantages of speed and cost savings if you have to do any modifications on site. And the factories often get those wrong, in those drawings. You might submit them accurately, so you have to really check the drawings that they send back to you.
Those come with electrical and plumbing already in the walls, or that has to be added in?
The SIP panels, they do not come with the electrical and plumbing in the walls. They do come with channels for the electrical, but there's no wiring in them. You can get them in pieces anywhere from 1 foot wide up to 8 feet wide, up to 30 feet long. The bottom picture here shows basically what a true panelized kind of a system is, where you have all of the doors, the windows, the siding, of course the structure is all put together in a controlled environment, and then and sometimes even the wiring is put in the panelized systems, and then they're put together and shipped. What we've done in a lot of these is we can get a whole house on a shipping container. And it's because the walls, each of the pieces are separate, but they're big chunks of a house. And the inspection process does not have to occur at the factory, because all of the components are still visible when they arrive on the site and are assembled. So all the inspections can occur on the site. These are some examples. These are all local. none of these are in the city, but they're all, one was temporarily in the city at the park for Earth Day, the lower right one. The other two are in Montecito. One's in Lambert, on Lambert Road, and the other's a guest cottage in Montecito. I think the thing to indicate here is with the panelized, you can get the whole variety of styles. You can be contemporary, you can be traditional, you can pick basically any materials on it. This is the interior of the one that was in Lambert Road. As you can see, you can have volume ceilings, which you don't get in most of the manufactured, and you don't get in the modular. We started the built-to-ship division in our company about 7 years ago, and mostly to respond to the housing interest in Hawaii. And it really was designed to respond to, which was the case in Hawaii, but other areas as well, where labor and materials were issues. Whenever the surf was up in Hawaii, all the builders would go surfing instead of working on the job site. So, you know, it was very tough, and it was a very extended schedule to get something built in Hawaii. You couldn't get local materials because the materials all came from either Asia or from Canada or the U.S. So we started putting all these packages together and putting them on shipping containers and taking them over there. Get one, pretty much a house up to about I think we right up against a 1,000-square-foot house. Get everything on the container. That was all the appliances and everything, and then assemble it there.
Why don't they ship the parts and assemble them on site? Wouldn't that be easier?
Ship the.
Why don't they just send parts and assemble it on site? Wouldn't that be easier?
The question is, wouldn't it be easier to just send the parts, the pieces, and build it on site? Well, that takes care of the material, but doesn't take care of the labor issue. I mean, you still have labor. One of the things that you can do by panelizing it is you can speed up that process. The permitting is basically the same permitting process and inspection process for custom homes. It's the local jurisdiction. You have the potential of saving some time, just like with the modulars. You can double up when things are occurring. You can be doing all the site work, the foundations, the utilities, bringing those in while the panels are being assembled, so that you can speed up that process. Construction time, we're finding, is about 4 to 5 months with our. Got to lock in here. This again shows the different styles. You saw the one in the lower left. The upper right one was one we did. We sent about 3 or 4 of these down to the Katrina area. They have kind of the Cajun style. You can see some of the gingerbread stuff that they like down there. The one in the upper left is on Hollister Ranch. It has a tile roof and basically Adobe veneer on it. So you can do all kinds of things. That took a little longer because of the Adobe veneer. So it's like laying up brick. But the interesting thing on that one is 85% of all the lumber materials in it were left over from 20 years of our building custom stuff. And we had a big pile of it, and we just went through that and were able to use those materials. The cost on these, we find that for us, about $250 a square foot, including, and that's including everything, shipping, utilities, and turnkey. The more they customize it, then it starts pushing the cost up, getting into more customized materials. We pay a lot of attention to the greening of them. I think all of these would probably, that we do, would reach the platinum LEED for home standard. Especially in Hawaii, we pay a lot of attention to natural ventilation. We use radiant barriers. These are all standard things we do. We pay attention to the overhangs to make sure that the windows are shaded. Lots of daylighting, etc. So the advantages of these is it's like a stick-built thing, so that everybody's familiar with it. The local jurisdiction, and I think for the city of Santa Barbara, what's of interest is that they have full control of fitting in. you can make these so that they fit the regional architectural vernacular. The manufactured homes never fit the regional vernacular. The other thing is the regional and to some extent the modulars don't fit the site specifics. These are designed for a site specific. And I think, in my thinking, that's one of the really important things to think about in terms of sustainability, that you site the building on the property so that you're taking advantage of the solar access, you're taking advantage of the breezes, the views, etc. Good waste reduction on these. Time and cost can be a little bit below, depending on how much customization a client wants. A lot of flexibility. The overriding principle that we used in developing this was resource efficiency. And to me, that's a very green principle, but all of our structures fit the 2-foot modules, so that, because almost all building materials come in 2-foot increments. So if you can stick to doing something that's 16 feet or 20 feet or 24 feet, you don't have to cut materials, so it cuts down on labor, and you don't have any waste, and you're getting more square footage. So we try to, even when we customize these, we try to make sure that people are staying within that principle in the design of the structures, and that's what helps hold the cost down and speeds up the process. So far, I think ours are the only ones where we've tried to pay a lot of attention to the high fire area. I'm not saying this couldn't be done with the others, but it'd probably be an upcharge. And we've learned so much about how to build in ways that the structure's not going to burn. It's not just the structure by itself, it's the defensible space around it. But we can basically build structures that don't have all those weak links that have led to houses being burned down. And the code keeps upgrading, but we try to go beyond even what the code does to make sure that they're going to survive. I think that's it. The drawbacks, the cost and timeline is right around what customized stick frame building is. And the majority of the work occurs on site, so you don't gain as much of the time advantage as some of the others.
Thank you. That was a very good presentation. And now this is the time for questions. If you have questions, we'd like to put them on mic and have them answered so they can be properly recorded. So are there any questions? Raise your hands, please. Any?
Thanks, Dennis. Is this on?
Are there any drawbacks or issues associated with the panelized or pre-cut homes in regards to slope?
They're about the same as they'd be for modular. I mean, you can accommodate them on a slope, but your foundation has to be taken into account. All of these systems have crawl space systems, so when the manufactured, you have to pretty much have a flat site because that's part of the speed and so forth. The others, you can adjust the foundation, but it would have to fit in with the overall design. If you're doing modules, you might be able to step them on a site, for example. And we can certainly do that with the panelized and the pre-cut systems. You know, each component of the house can be computerized and pre-cut. Even the wall systems, we're starting to see that in. So it gets a little more advantageous towards the panelized and pre-cut. The modulars, you can do a little bit on that. The manufacturers, you'd be out of luck on. Good question.
Just a point of clarification. As far as slope, with both the manufactured and with the modular, one of the big issues is whether or not you can get a truck in there, because the trucks are basically semis that come in there, and then you also have to have a crane to offload the units. So that's a big issue. And then the other thing, I just want to clarify, I think the dimensions that we base the built to ship on are 4-foot dimensions, not 2. Correct?
Well, they're preferably 4.
4. Okay. Sheer panels and such come in 4-foot dimensions.
But most of the building materials can come in 2-foot too. But Betty? Oh. But the getting a crane into a site, we looked at doing that little demonstration house with Jaime for a couple sites in the city, and it turned out to be impossible to get the cranes in up on High Road in some of the places, or down on High Road off of Mountain Drive. Some of those were tough.
My question is about the combination.
Which I think you mentioned the Pedregosa house was actually a combination of modular and then some on-site design construction in the middle. Do the companies explain that or encourage that in any way? Because I think that could be a good solution or something we might see in Santa Barbara where people buy portions of it modular, but also site design and construct, say, entryways and, well, of course, landscape and entryway features, and then maybe certain features of the home would be on-site constructed.
Unfortunately, they don't encourage it. I think the only one that I know of that has done that is Michelle Kaufman with that particular model, and they're kind of moving away from that. But it was a very nice feature for the Pedregosa because it enabled that center section to really fit the site better.
Yeah, so the panelized, you work with the architect. In other words, the architect designs based on a module, and then he just brings his plans to you or to whoever does this, and then you people panelize these things in the factory. Is that the way it works?
Basically, we're usually part of the process with the architect, so that the architect is clear to understand what the module's requirements are for the efficiencies. But within that parameter, that single constraint, you have a lot of flexibility on design. And it is a collaborative process.
Yeah, Dennis, you may have answered this already, but on your panelized pre-cut system, do you need to have a raised foundation, or could you do it on a slab?
You can do it on a slab.
You could.
Because the wall sections are separate.
Right. Do you prefer a raised foundation? Is that kind of is there some advantages, in other words, to having that?
It more is site determined. I don't think we have a preference on it.
Okay.
There aren't a lot of flat sites around, though.
No, there aren't.
As we all know in Santa Barbara.
Dennis, I have a question from staff. The central issue, I think, in Santa Barbara, the city of Santa Barbara, is the customization of what our boards and commissioners can do to request changes to these units. And so the question I have is, have you had any experience where you have had upgrades to the elements to the exterior sort of visual skin of the building, the window upgrades or roof upgrades? Or is there a lot of selection there? So someone who comes to the city with a specific appearance, what are the actual components that are interchangeable?
I don't think we've had any firsthand experience with that, Jaime, but the Pedregosa house could have had that. I mean, they did a lot of customization on it. They just got under the wire from not being required to appear before the ABR. And the reason for that is I think all houses in the city now that are two-story have to go before ABR, and so they just they skirted in under to avoid that issue because I mean they weren't sure how the city would respond to it, and that was a controversial project at the time. It's a Core 10 skin on it if you haven't seen it, but I think it came out quite beautifully. But it was a combination really of the landscape and some of the sighting stuff that I think saved that. But now, if that project came before the city, you'd be able to make those modifications, ask for those any way you'd want. That would not, of course, happen with manufactured.
As Dennis said, our company hasn't had experience with that, but I spoke with Michelle Kaufman's office yesterday, and they said of the 40 homes that they've completed, about 20% of those have had to go through design review process in one community or another, where there have been requests to change out a window or to change a roof line, and just that they've been able to do that, but again, it goes back to making it more of a custom unit as opposed to a pre-manufactured or pre-built home, and it does increase the cost associated with it when you have to go back in and change anything from their standard format.
Yeah. I think the follow-up question was directly related to the customization and our boards being criticized for increasing the cost if they're asking for changes to these components. And so if there's a way to have an understanding of the selection available for these units, that would certainly help the boards and commissions understand what's fair game as far as upgrades and things that could happen.
I think the key would be for the project to come before the boards early on, before it gets locked in. And then you don't lose some of that efficiency. I mean, they still have certain formulas that they want to meet, but within that, there's quite a bit of latitude. And if you can, I mean, like, that didn't have to be a core 10-sided building. If that was caught early enough, then they would change the cost at all of the project. So I think any availability would be clear on what you're asking.
I think just one other point on that, Jaime, is that I know with Michelle Kaufman's units, you can see a list of what all the potential options are as far as window styles and such. I know with the panelized systems, we can use any type of window. We can use a low one versus a Marvin, a double hung versus other choices. So there's a lot more flexibility in the panelized or the pre-cut systems.
And I assume that applies to roofing materials, correct?
Yes.
Right. Okay.
A lot of the modulars are flat roofed for the contemporary reason we have. I think the thing that I would love to see in some of the modulars and that we're trying to do is really pay attention to the fire issues, the wildfire issues. I mean, we're able to do things. Our approach is to try to do structures without venting, roof venting by using isonine and so forth, and complying with city codes to obviate that need. The same thing for foundation vents. If that becomes a part of the conditioned space, you don't have to vent it. And that's been a real vulnerable spot. In this last fire, one of the things I learned is it's not only important to, and they have new designs of vents that can basically keep the flying embers and the sparks out by baffled vents and so forth. But you still get smoke into those things. And smoke is a real damaging thing in wildfire, even when the house survives. And we found so many of our neighbors that just have, they're going to have to strip the walls in their house. It's so bad. It just permeates everything. So if you can avoid those vents, you have potential not only of not having the house burn, but even the next step down of not having that intense contamination from smoke. So, and then paying attention to how porches and decks and terraces and things like that are done. And most of these places are not thinking wildfire, but we locally are super aware of it now, and we need to just be rebuilding in ways that cut off these weak elements, these vulnerabilities in houses.
How about vents that can be opened or closed throughout? You can put options, so if fire is near, you can close the vents.
Questions about vents that can be opened or closed during a wildfire. That's great if you happen to be home. I mean, we had 10 minutes to get into our place before the whole canyon was blocked off, and most people were at work that time of day. So I mean, if you had a remote controlled vent, that would be super. Then I'd say yes. And so my approach is go for the maximum protection you can, because there's so much investment in a house.
Just getting back to Michelle Kaufman, I heard recently that the production shut down, and since you said that you talked to her just in the last few days, do you have any information about that?
They're going through a rethinking process. Their factory, that they owned a factory up in Washington, and they've sold that. So they've been working with two other factories, and the ownership of those factories is changing. So they're kind of thinking how they're going to continue to move forward. And the factories are a big issue. I mean, the reason they bought a factory was to control that process. And the house on Pedregosa was I think the second one out of the factory after they took ownership. There was a delay in the production for that reason. But even with that, we had to take all that siding off and weatherproof that building because it wasn't done right in the factory. And they picked up the tab on that, but I hate to see stuff having to be done twice on buildings, because nobody wins when that happens.
I heard it from a local contractor who's doing the house, and he can't get any answers right now.
Yep.
He's weighing.
Well, what they're looking at, because I did speak to the office yesterday, is looking at factories that they can work with on a case-by-case basis to produce a home. Now, the issue with that is some of the quality control aspects that are inherent with going with a factory for just one home. Can you really control it? But they're also looking at other options, possibly going to a more panelized system versus a full module system. And they're also looking at Michelle just being an architect and working with a local contractor, that she offers the design and the local contractor constructs the home. But this is all in flux right now. Last week, their phone number and address was on their website. This week, their phone number and address is not on their website. So they're really in a transitional period. They asked us not to say anything about that, but since you brought it up, I'm just going to be honest. So.
Yeah, a lot of these modular companies are still struggling to find the optimum way of producing homes. They do a lot of things well, but almost all of them still have weak elements in that process line. And a lot of it, as I was suggesting, is between what their team does and what the local team does. I mean, that coordination needs to be really good to have happy clients.
And just to, one other thing, to just speak in favor of Michelle Kaufman and that they're still trying to continue, is they were just here last week speaking with a client up in the T-Fire area about constructing a home. So they're still alive, but in transition.
One last question before we transition?
Thank you.
Next, I'm going to introduce Larry Thompson. Bill and Bernie, if you want to sit up front, we saved all these seats for board and commission members. I might just send out an email of the exact schedule to the rest of the board and commissioners, see if they can join us for later presentations today. But if also we have staff popping in and out today, I know, so if anybody feels like moving over a couple seats to make it easier for people coming in later to sit down at the edges, that'd be great. And I think that was it for the housekeeping things. We will bring down some water at the break, which is coming up after this presentation. So, passive solar. We're really excited to have a presentation from Larry Thompson on passive solar because this is a topic that is so simple to implement once the concepts are understood, and it doesn't necessarily have to cost a lot of extra money. So it's a great sustainability topic. What's also great about having a local training like this on passive solar is that with our location, there's different mathematics that come with where you are. And so having a local expert like Larry being able to share with you the numbers and the math that goes with local examples is really unique. So he has a lot of experiences. He's been doing this a very long time. So with that, it'll be 40 minutes with Larry, and we'll have question and answer as well after about 30 minutes.
I guess I don't need this, or... Yes. Hello. As she's mentioned, I've been at this since '73, and it's been an interesting journey. And I'm going to bring up what's really a phrase keeps following me by Goethe that said that when you take action, Providence many times steps in and creates impossible results or things you would never expect. And you'll see some of this. But I need to give you a little bit of backup before we get into the show. As all of you are, I'm preaching to the choir in a large degree here. Most of you understand that we have a crisis. We've had crises. But some interesting facts have emerged. I don't know how many of you saw Ed Mazaria's presentation at UCSB, but one of the interesting facts was that we've all been targeting automobiles as the big contributor to global warming. But Ed is saying through a long extended study that over almost 90% of that amount of auto emissions is being produced by buildings worldwide toward global warming. This is not just a industrial automobile generated problem. And Walter Cohn of UCSB noted lately that a remarkable fact that I've actually wrote an article including, and that is that enough energy falls on the surface of the earth in one day to provide all of our power needs for 1 year. An incredible fact. Obviously, we have 2/3 of that surface in ocean, but that's our other passive solar collector, the Earth. We have the ozone, the layer, the greenhouse effect. The water is the thermal mass. We have this incredibly delicate balance, but it's possible only because of passive solar in a great sense. Solar collection systems have no emissions. We don't have the problem of gases. And part of that ozone layer, strangely enough, is due to termite outgassing. It's just a weird. For every person in this room, there's 2/3 of a cubic acre of termites worldwide. It's a bizarre and stupid fact. But there are things all over the world that are contributing to this envelope that we have. We can power buildings, everything, literally, with solar. So it's the most viable form of energy in the world. It's accessible everywhere. In Rotary, we're working on projects in Kenya right now with our club and others in Peru to promote these kinds of sources. But where are we now? I'm doing this quickly because I think you need a little context. And I'll give anybody who wants, I'll give you a summary of these notes later on if you're interested. In '51, I was an amateur astronomer studying the sun in liaison with Mount Wilson Observatory. I was aware of what we had from an early age. 28 years later, I was the head of the CCAIA Energy Task Force, which prepared a white paper proposing the Title 24 building codes that were the first energy budget system in the world for building compliance. In other words, it wasn't just a matter of how well insulated your building was. You got credit for having passive solar or solar hot water. And at that time, photovoltaics were a minor kind of upcoming piece that weren't really that well recognized. And still, I think there are efforts to get that included. Ultimately, that morphed into a position as chairman of the State Energy Advisory Committee that promoted and I wrote the paper that actually codified Title 24's energy standards in a room of 5 people as advocates and about 400 people in wheelchairs waiting for the next piece of the Title 24 activity. You can see where the priorities were in 1982. It was approved, but the Senate, before it was approved by the Senate, there was a committee hearing. The developers tried to undermine it through a classmate of mine, another architect in Southern California. And there was Gary Hart and Senator Green. And I had to explain to them that the Indians in Arizona knew about passive solar. CEC had gone through a luxurious process to show how every climate zone in California would benefit from a south-facing glass building, other than the highest, most difficult sites in the upper mountains, Zone 16. And as many of you know, those zones of 24, Title 24, are very general. What we may say is Zone 6 in the south coast here actually has something like 20 different climate constituents amongst it. I don't think anybody's really ever defined it all. Any rate, the Senate basically said, we don't want to require people to have the proper orientation. We will take the orientation at random. And, of course, anybody knew that that defeated the purpose of passive solar, which could only be enabled by south-facing glass. I gave a speech to Calbo down in Ventura, and 2 months later, Calbo said, we cannot enforce these standards unless orientation is included. So, in fact, Calbo kept the thing on path. 2 years later, California went from number 47 to number 2 in the nation in terms of energy conservation. And what would have happened to us in 2000 with the Enron meltdown if we hadn't have done that. It was all providence. I mean, just amazing sequence. Right now, another 28 years later, we're finding a tremendous demand for architects to implement passive solar strategies in buildings. And I've recently seen this in projects with the UC system, where it's become a prime mover. We are at a real, I think the era of Obama has set us really cleanly in this path. Passive solar, we can probably hit the show right now. Do the first slide. Maybe we can go through this. We've already covered that. This is we could maybe cut some of these front lights. Is that possible? Nope, back. There you go. This is a project we used to win the state solar competition. And I'm sorry that it's not simpler because of the distance you're experiencing this from. This sort of typifies, though, many of the approaches. This is a south-facing wall. This is a frame house, very simple, but it does have a clear story. I was working with Irv Thomas at the time, who I'd worked with for 5 or 6 years with CEC and doing their energy demonstration project. And Irv came up with the idea of a masonry wall in the middle. Obviously, the 3 components or the 4 components that you have to have in the system, obviously, is solar access, and you need glass that will let light in. And today we have tremendous options in that regard. And you need thermal mass, and so conveniently is in a slab, concrete, masonry, in some cases doubled up gypboard inside the building. These are very common ways of storing heat to be re-radiated through the night in a winter situation, or actually to soak in heat on a summer day with other strategies to help cool the building. What's also a factor here that's not shown is that all this south-facing glass creates glare. And this backlighting up above helps reduce that glare, or if this were all one room, a window back here would help do that, in which case we would have a wonderful natural ventilation system through the house. And we'll show a few examples of that. Next slide. You get that? This is a, unfortunately, poor copy, but here we see the same principle. The sun coming in, it strikes the surface. If that's a dark tile surface, it'll have optimal performance to help store the heat, re-radiate it at night. And then if we're a little craftier, we can take, and also the heat that's collected on this masonry inside can be collected at the top with a return air grill, pumped down through a rock bin, and then this back portion that would normally be cool can radiate heat at night. So the options are easy and manageable. Summer cooling, other things happen. Chimneying is obviously a big thing. To have a skylight that's operable, that can vent out heat in the backside, or a clear story. Also, if you take and reverse this cycle that I told you about and actually pull in cold air from the outside through the roof or whatever and pump it through the rock bin during the early morning hours and charge it with coolth, if you will, during the day, during the day that can be pumped up and dumped out of this return air grill at night and filtering down as 60-degree air we found in many projects. This really lends itself, this rock bin approach really lends itself to warmer, drier inland areas where you have good heat extremes. In Santa Barbara, we're blessed with this incredibly temperate climate. It doesn't become quite so strategic unless you're lacking with other basic passive solar strategies. Going back, this was the hot item back in the 70s. This is the Kittle or Bear house. And there was a whole thing about envisioning a house as a flower that opened in the day, collected the heat, and closed down at night. And this house basically had a lot of movable panels that could close up at night. The problem is, of course, who wants to buy a house like this, or who can relate to this kind of a house. But it was an interesting object lesson at the time. Rather than go that route with Paul Rellis's house, we employed something at Irv's urgings and built by Dennis Allen, as I recall, and an inspired crew. This is a block wall covered by fiberglass that is known as a Trom wall. The wall collects the heat. The heat is siphoned up to the top, and then it's either blown out by a fan or thermosiphoned into the house to heat the house naturally. And of course, by dampering it, you can change its performance or negate it. The only problem being that all this wonderful south-facing view is totally blocked by a wall. And also the cost of this wall and all the ship's hardware that had to go into it to make it work properly. I think over time we found that that was really kind of cumbersome. And then simultaneously with this, in the mid-'70s, we did CEC's energy demonstration project. And of course, it was an earth-tempered building that had the earth from the back side of the building just rolling over the top. And it was all supposed to be planted with lush, beautiful flowering shrubs. And of course, it looks like weeds actually wound up here. This being a greenhouse inside water columns. So we were collecting the heat. Water has a huge thermal mass capability, big fiberglass drums. The performance was very well documented and very successful, but the question is, who would use water columns in a house? I mean, it's aesthetically and visually kind of, looks like something an engineer would do it. It's kind of very, very tricky, but not too practical. We also had upper lighting and collection in the back. We had some, you can't see it here, but there was some passive solar on this side. But it was a melding pot of ideas, and people came forth. We had composting toilets that served the space. I think the energy crisis died off in the early 80s. It kind of fell into atrophy, if you will, in terms of its application or the energy that went into it. But after that, we kept coming in with houses. This is up on Nirvana on the west side, which had passive solar that didn't rely on some of these rather cumbersome techniques. I think the thing we learned is that you don't have to get into overkill in Santa Barbara. We have a temperate climate. If you don't have a great difference of temperature outside to inside, you don't have to reach to those extremes of performance as they would in the Swiss Alps with the Trom walls and all that sort of thing. So we simply got into the habit on every project of putting south-facing windows, maybe a little bit of an angle on a building to get a little varied collection so that maybe a room that's used later in the day would get some solar collection or better light. A strategy that was very common before the turn of the century. I don't know how many of you lived in houses in which the living room might have been on the northwest, the dining room on the southwest, the kitchen sort of on the south, the bedrooms on the east. They were thinking about how energy was used during the day in the planning of the house. It's that same kind of thinking that because now we have more expensive energy, or we're coming to it, that we have to become more aware of. This is a site that was developed back in 1986 up on the Riviera, and there was an this is not really a road, but a path that was used to build a house to the left, and these are 5-foot contours, so this building has 35% slopes, and you can see that, well, we were aware of the energies of the site. We had views all around to the south, to the west. We had cool winds coming from one direction. We had onshore breezes over here. And we had lots of rocky terrain back here, 8-10-foot boulders. Very little natural vegetation. So in order to begin a project, before you do anything, obviously, you need a good green agenda. You need to identify what you are really after in the project. Go out on the site for hours if you can, at different times of the day. If you have that luxury to get the sense of what is happening there in terms of the wind, all the little microclimates on the site, vegetation, access, all those things, and to get a sense of the place. I think it's good for any design process. We came up with what is really more a schematic of necessity. Because we were confined to this rather narrow shelf, obviously you have access and you have more of your guest-related spaces, living rooms, that sort of thing, entry, kitchen serving, the dining room, family, and as you go back in the house, it becomes more private. But we did plan in several yards, which is rare on the Riviera. But in doing that, we also thought, well, look, aesthetically at least, and in terms of living in the space, wouldn't it be nice if we had a sort of a broken path? In other words, here's a yard, an entry court, a terrace, a shade court, if you will, a portico deck, and a backyard, so that at all points along the way, interest changed, the character of the space changed, because we were really locked into this, what typically could be a barracks-like structure. At the same time, we'd like to create a pocket, say, for a main living area, because that sheltered it from the northern winds. Actually, it kind of cooks in the summer is the only problem. But we also had the ability to preserve air film, which is about 1 R value in the resistance of heat to go through a building, just by creating a more irregular building profile, vertically and in plan. This isn't a house that you're going to Dennis is going to build and ship to Hawaii, obviously. This is really a whole different piece, very custom. But this is more of the manifestation of what I've just told you. You can see that not only do we have this change of spaces, but we have different angles of the building. And it's been shown that projects that have 45 degrees of south orientations do collect solar, passive solar, but it may be 70% of what they would if they were straight south. So if you're in San Francisco or Santa Barbara on a 45-degree grid, you simply have to have 40% more glass to do the same job. And that does put a pinch on, say, something like a Spanish colonial project, which really wants a lot of wall area versus window area. But I think this is manageable. This is a cross-section through the project. It has some interesting ramifications. This is obviously, this is the south. Here's the sun. The sun comes in the window, heats the slab, which radiates at night, just as before. The same thing above. There's a mezzanine, and bedrooms up above. No big deal. A skylight that vents. But we also did put in the rock bin so that during the winter day, we could pull that return air, heat this hot air at the top down through a duct, charge the rock bin, re-radiate it at night in the winter. It works very well. The problem really is mold, and that's why having a site that's away from the ocean, away from a lot of moisture, I think is very key to use this kind of hybrid. We also have a concrete pipe that serves the forced air unit for the backup. That's we call it an earth duct. Pre-tempers the air before it gets to the furnace. And frankly, it might have cost us $1,500. I don't know that we're going to get a return on that within 15 years. Whereas all of these things we were going to do anyway. It was just a matter of distribution and design to utilize it. So within a year, we had all of our costs paid back on the passive solar aspect of the project. Another thing that also happened, that on a very windless day, with all the thermal rise on the front of the building on the south side, this rocky shade court would produce enough cool to be drawn through the building just by the air moving away here, pulling it out toward the south. This is a floor plan that ensued, and as you can see, here's basically a living space. It has sort of a hexagonal bay window. Lots of tricky relationships here, but this is about 25 degrees off of south. This is about 15 or thereabouts, and the bedroom wing over here, which has probably plays into this in the least, is probably a 35, 40 degree angle with city views. Because two of these rooms have carpet, it's the lowest performer, and it probably uses conventional heating maybe 2 or 3 weeks out of the year. The rest, none. So we have a footprint along with about a 5.5 kilowatt photovoltaic system and solar hot water heater. Our total energy bills are about 15, maybe with the gas for cooking, maybe $25 a month on a 4,800 square foot house. So not including the auto use, we're in pretty good shape. This is the interior that shows there's a return air up in this area, and down below is the collection area. This is all tile, and the heat percolates up, flows over, and then it gets pumped back down through the rock bin over here. Looking the other way, you can see there's some backlighting due to skylight, some venting. This is a double door use that goes out in what we call a shade court, and the kitchen area beyond. This is the entryway. Well, this is kind of exciting, but there are doors and windows up above that chimney heat out of the house, and the stairways are wonderful, if you can get a good photograph. This is the exterior of the house. Well, it's obviously a very custom kind of endeavor. And this bulge right here is where the earth duct comes in from all the way down below into the heater compartment. And I think the key point here is that the house doesn't have to look like a barracks. It can relate to Spanish colonial, Mediterranean idioms, partly by variety of some of the openings. I think I have another one here. Yeah. Here we have Mirador windows. We have a lot of inset features, and especially when we get into commercial buildings where we need a lot of daylighting, we can create colonnaded glazing elements that help pull it into the Spanish colonial theme without becoming a hindrance to the amount of glass we need for daylighting. This is an apartment building downtown, and these balconies are only about 3 foot deep in here, just barely enough to get a chair out on them. But this particular side of the house here is probably 15 degrees west. This one over here is, I don't know the math right offhand, but it's within the realm of early morning buildup on a passive solar basis. So we took this whole element and skewed it on site and created through ventilation and passive solar on this side with good mountain views on the other, the Riviera. There's a house. These are problem houses, and this is where you learn the most. This house had really no solar access on the south. There was trees, a neighbor that wouldn't cut the trees, all those kinds of things. So even though it was a modest attempt, we put in a clear-story window that brings a lot of daylighting in and also builds up. These are plastered walls so that the light coming in would give us some solar quotient. And it has a certain dynamism. When the upper windows really are a real lead-in to very aesthetic light, design with light. The filtering effect has a tremendous and rather dramatic effect on interiors. That doesn't belie the solar quotient. This is a house up on the upper north side. This is in the county. And this is the most difficult kind of house to relate to passive solar because all the views are northwest to northeast. Beautiful mountain views. So the owner wants to have everything. They want these endless views all the way along the north side of the building. What can you do to offset that in a way that keeps the house from being totally, an energy monster? And it's also spread out. One of the ideas was a big entry courtyard, another courtyard here, lots of surface area, lots of room for heat to get out. That kind of, which is wonderful in terms of a place, don't get me wrong, but it's built up more wall area to lose heat. So what we've done, you can see this is the north arrow here. We have places where we have put in full 7, 8 foot wide elements that relate to solar orientation. We even have a little bit of something here in a little deck, which gives us some protection. And one of the elements with passive solar is you have to have that overhang. If you don't have that control during the summer, you'll get killed. You'll get too much heat coming in. If you're close to the beach, you won't have to have so much overhang. But if you're in the inland valleys, it's incredibly critical, especially when you come around to more westerly exposures. I think most of us have seen that effect. So by doing some planning here, we also have a tower to vent the hotter air and windows to get more passive solar. We have rooms here that get some kind of light coming in later in the day. But the house turned out, even though this is like an entry view of the project, which is a spec house, believe it or not, didn't turn out too badly. It had some things, some refinement. This is more the Vaughan Ordinaire on the hillside. Here we have a southeast exposure for early morning buildup. It might be 20 degrees off of south. These are more directly southerly. But we don't really have this big expanse of glass in one place that is so often the problem. But the spin-off of all this is daylighting. This is a church that really defied all, how would you say, normal consideration for the occupants, because here we have a 40-foot skylight going down over the altar, and yet people would still sit down in here in the summer months with the light coming in their face. They finally put some canvas in there, which we worked out to help moderate that to some degree. The whole idea being connectivity, oneness with the cosmos, sort of fit into the whole spiritual message of the church. But in a hallway in an office, to put in a skylight, to put in some baffling of light to help bring the loads down. And then in a spa, we have skylights that have little hoods on the top to keep the summer rays down. You can build a tremendous amount of aesthetic quality. The restaurant, we see the backlighting up above here. The light in here really makes these slides hard to see. But basically, we're having long hanging lights, and this existing clerestory really helped pick the whole space up. Cut light bills. Here's an office, and same thing, but we were also able to get some solar in here during the later part, mid-afternoon, to help pick up that space as well. Anyway, to wrap it up, this is basically a shot that shows how do you handle large glazed areas on Spanish colonial buildings. I mean, you have to recess them. You have to do things to vary their size. You know, most of you know the drill here. You have to individualize these openings, but if you can't, you can create some kind of order through a colonnaded approach. At any rate, obviously, design and engineering have to come together here. We have a company called Sunplan that does the Title 24 and all that, and there are others in town too. But I think really the next step in the action sequence is you. You've got to be proactive on this. We have a real problem. The oil will run out. It might be 60 years, but we're what's here now. I thank you for your time.
On the eaves, you were saying that if it's near the ocean, it could be a little bit less of a length than if it's inland. And what's a typical eave length that's good for passive?
Well, it depends on the angle related to south, obviously. I think the key thing isn't so much the beach as when you have a very temperate climate, obviously you have a much lower problem in terms of heat gain and heat loss. It becomes less critical. If you're up over the mountains here and you're in the inland valleys, which is where this passive competition project was, you have to be very careful about this. I mean, you're going to have serious implications, especially with skylights in the summer. They will burn you up. You have to resort to things like clerestories and have some overhang on them. And one of the big problems is that clerestories on Spanish colonial buildings that are shed clerestories just look a little bit 50s contemporary. It's the mine shaft school that we're constantly struggling with. And yet, many times we've been able to put a little gable up there, kind of mute it a little bit, pay a little extra price, and get the same value. But it's a matter of proportion. Obviously, if the window is 3 feet high, or it's, say, 3 feet below the bottom of the eave can be further back than if it goes all the way to the floor 8 foot below. So it's a proportion, it's an angle issue.
Why not just say, just build a house, you know, the way they wanted to, then throw some solar panels on the south side of the house? Why, you know?
Solar panels will be photovoltaic or water, basically. But what passive solar does is it doesn't involve the equipment. It doesn't produce electricity. It treats airspace without having to go through that extra step. One of the questions that you're all going to have, well, anybody on a design review board is going to have to deal with, is the plastic thin film photovoltaic revolution that seems to be coming in a year now. In France, they have buildings all over with a black shingle that looks like asphalt. But because it was cheaper, they're covering everything with it. Well, now you have people that are maybe more desperate over time for electricity, and they can undercut. Our electrical will be paid for in 6 years. I mean, it's in 12 years, we're done. It's free for another 20. So it is very persuasive if the costs come down. With thin film comes through, people are going to want to put it everywhere. And how are you going to handle that in Santa Barbara? That is going to be really a hot item, and there's going to be some very careful thinking about that. We've also thought that if you do have to get into the collection side of this, and we weren't really, she didn't want us to get into all this, but you have to think about things of baffling, dividing, doing things to help soften these big expanses. Whole different show. Yes. Pardon? We don't know yet. How reflective is the thin film? We don't know really what we're dealing with in terms of the nature of these products, because they're being developed. And they're being developed at UCSB in part, with people flying back to Korea and China right from good old Santa Barbara. I think, and then we also have things like reflective coatings on skylights. How is that going to be handled? The church, for instance, could only have done that huge skylight with a reflective coated skylight product that was quite expensive, but it only lets in about 50% of the light and only about 20-30% of the heat. So that is, frankly, probably right now more of an issue, and it somehow slid through. But with the collectors, I think it's a matter of color. Collectors are going to be black. If somebody could come up with the Van Dyke Brown solar collector, what a huge difference that would make. So hopefully we will have choices, but we just don't know. So.
Thank you. Thank you very much.
Do you have any questions, Simon?
No, I think so. We're going to take a 10-minute break. Feel free to walk around, and we'll commence our next presentation at 10:50.
Right on schedule. Very good.
We have.
Well, we're going to go ahead and get started with our next item, which is Lindsay Taggart's here from the Community Environmental Council. She's a lead AP and a building energy specialist, and she's been working with city staff on this great chart that's over there in the handout section. Make sure that everybody picks up this one. And the reason why we're doing a comparison of the green building certifications today is because we have a really great program here in Santa Barbara, which I'm sure you're all familiar with, the Built Green Santa Barbara, that by the Santa Barbara Contractors Association. But there's also a number of other green building point-based programs throughout the country and various levels that are worth taking a look at, because we also allow those as substitutes in certain regulatory situations, so which I'll go into after Lindsay does her presentation of the programs. So I guess, yeah, then if you want to go ahead and pick up the handout that I have, that's over there as well, and we'll go into that after Lindsay's presentation is over. So just also wanted to just really thank you, because this is a really wonderful document to have. I think so many of us have been wondering about all the different aspects, and so we're looking forward to your presentation. Thanks for coming.
My pleasure. Thanks, Heather. Okay, so there are many different green building certification programs available to builders of both homes and commercial buildings of all different types. So I'm going to sort of do a little comparison of all of those that are out there currently. But just keep in mind that new ones are being created as we speak and are going to be continually launched as this field of green buildings gets more and more popular and more pertinent as we need to continue to save energy and all look to save costs in terms of operating throughout a building's life. Just a couple of facts. The average LEED certified building uses 32% less electricity and saves 350 metric tons of CO2 emissions annually. So as AB 32 and other climate change regulations start coming down from the state and federal level, green building certifications are a great way to achieve some of the goals that those legislations are imposing upon local governments and are just great for personal peace of mind in terms of home construction. These facts up here are all LEED based just because the U.S. Green Building Council, who runs the LEED program, has done a lot of research to verify the performance of LEED buildings, and so the data associated with LEED buildings is easily available. LEED certified buildings are also commanding rent premiums of over $10 per square foot compared to their competitors, and they have a 3.8% higher occupancy rate according to recent studies. These rent premiums and occupancy rates are due in most part to an increased comfort and increased indoor air quality. LEED buildings are also selling for an average of $171 more per square foot than their conventional competitors. So green buildings on average are selling for more, they're renting for more. Green schools have been showing an increased performance in their students, less absenteeism in teachers. Other LEED commercial buildings show less absenteeism in their employees. So there are a ton of really great benefits associated with green building programs. Just a couple of other simple, quick facts for you that I don't have on a slide. The way I look at it is green building certification programs really offer two main benefits. The first is that they take the guesswork out of a green building or making a building green. They provide you with a set of standards that you can follow from, straight verbatim from A to Z. And, in other cases, they also allow you some flexibility. They, in many cases, provide you with some prerequisites, standards that you have to meet in order to reach their certification level. But then they also give you a host of options or electives that you can use to sort of set your priorities and choose what is most important to you in terms of making your building green. They also act as a performance verification tool. And this is really key. As we all know, any building can be designed to operate at a certain standard in terms of energy efficiency, and it can be designed to reach a certain level of quality. But without a verification tool to come back and actually measure how energy efficient a building actually is and how it's performing, and without a tool to actually come back and measure the quality of a building, it's really left to the builder, and they build to a certain specification. It may not always be the specification that was designed into the building. So green building certifications actually come back and verify that performance and verify that quality and provide the building occupant and the building owner with a certain understanding that it's reaching those initial goals. So I'm going to go over this list of green building certification programs. The first few are all residential. There are a couple that address both residential and commercial construction, and then there are a few that address only commercial. I'm going to start with our local program, Built Green Santa Barbara. This program was initiated by the Santa Barbara Contractors Association.
Lindsay, I forgot to mention, we have Dan George here also. Dan, if you could just raise your hand, from the Santa Barbara Contractors Association, so he can help answer questions too about this program.
That's right. The Built Green program applies to both new homes and remodels and also small commercial buildings. Each of the green building programs is broken into a list of categories under which there are credit items that you have to achieve or are options to achieve in order to score points. The points add up. The categories under the Built Green program include integration, which is sort of getting all of the players together from square one and involving from the very beginning your architect, your builder, the homeowner, or the commercial building owner. Taking a look at issues associated with the site and the location of the building, water, energy, indoor air quality, materials for homes, getting the homeowner educated on operation and maintenance of the building. And then also this program provides you with a handbook and a guide with local resources. And Heather was holding up that guide, if you want to hold that up. These are the guides that are provided by this specific certification program. In this case, what you have to do, or what a building owner would need to do, is work with a builder or a contractor or an architect who is already certified through the Built Green program. They don't necessarily have to be a member, but the fees associated with the program are reduced for members. Actually, getting to the fees, it's around $250 to participate in the program and $300 to enroll your actual project. And those fees are reduced, like I said, for builders or contractors who are members of the Santa Barbara Contractors Association. Performance verification with this program is only required if you are trying to achieve the 4- and 5-star rating. So it goes from 1 to 5. If you go 1, 2, 3 stars, you don't actually have to verify the performance. You just hand in your paperwork. The paperwork is verified, but the actual building performance is only verified if you're going after 4 and 5 stars. And I understand that the verification process, one of the paths is to have a lead AP or lead associated professional perform that verification. Greenpoint Rated is a California program. It applies to only new homes and existing homes or remodels in California. This one has a large list, and you can read that over, of categories under which you gain points towards your overall rating. Again, this one, the paperwork associated with it and the checklist has to be filled out by a certified builder, a builder that is already certified through the Greenpoint Rated system. So if you are, if you're a homeowner or a developer and you want to get your building certified through this Greenpoint Rated, you have to work with a builder who is already familiar with this program. An inspection is required. The inspection is done by a rater who has been educated through the Greenpoint system, and the inspection covers everything from energy efficiency to water efficiency, material selection. And there are fees associated with that, $550 for enrollment of a project, and anywhere from $800 to $1,200 for the inspection, and that varies by square foot. LEED. Just a sticking point with me, this is LEED, not LEEDS. There's no S at the end of it. It stands for Leadership in Energy and Environmental Design. So it's actually an acronym. The LEED program, I'll get to the commercial end of that towards the end of the presentation. I'm going to talk about LEED for homes first. The LEED program across all categories is operated by the U.S. Green Building Council. As I was mentioning earlier, the U.S. Green Building Council has been at this for a long time, and so they've done a lot of research into the performance of their certified buildings, and they are actually one of the biggest players in the green building certification world. They've done a lot of great work in expanding the market for green building certifications, and there are a lot of LEED associated professionals in the world, as you may be aware. LEED buildings are certified. LEED people are associated professionals. So there's a little bit of a distinction there. LEED for homes applies only to new construction, and the categories break down into design, location and linkages, sustainable sites, water, energy, materials, indoor air quality, and again, awareness and education for the homeowner. If you were here earlier, you might have heard Dennis Allen mention that all of their built-to-ship homes would probably achieve LEED Platinum. I do want to point out that it would really depend on where those homes are going to be located, because under the sustainable sites and location and linkages categories, this program, along with many of the other ones that I'll be talking about today, really take a close look at where your building is located in terms of reaching resources in the community. They want to make sure that you are within walking distance to a bus stop so that you can use alternative transportation. They want to make sure that you are within walking distance or a bike ride to a convenience store, a church, a daycare. They want to make sure that your building is allowing you to act sustainably as you live in this building or as you work in this building. It's not just about the building itself, but the way the occupants interact in the community. Again, the LEED process, the checklist is filled out by a lead associated professional, and the lead process is also best approached from a collective approach from the entire building team. So from the lead AP that may be acting as a consultant to the builder, the architect, and the occupants. For Lead for Homes, a HERS audit is required. HERS stands for Home Energy Rating System. It is a national audit program. Here in California, it's run by the Energy Commission. And the fees for Lead for Homes are $550 to enroll a project, and then $800 to $1,200 for that HERS audit, again varying by square foot. Next, we've got our National Association of Home Builders Green Homes program. This one is fairly new, and it was initiated by the Home Builders Association to compete with LEED because they saw the success that the U.S. Green Building Council was having with their Lead for Homes project. It addresses that list of categories. I don't need to read it for you. Again, the checklist is completed by a builder who is already certified under the Association of Home Builders. And inspection is required both pre-construction and post-construction. So on this one, they take the inspection to a slightly higher or more quality assurance level, first inspecting the site, foundation, and then once the building is completely constructed and operating, coming back and verifying it for performance. And the fees, are average $515 for that inspection. Another new homes specific certification program is offered by the Building Industry Institute, and it's the California Green Builder. Again, California specific. Energy, water, wood. This one is the only one that addresses wood specifically, which is nice, and would touch upon the sustainably harvested wood products, FSC certified wood. IAQ, and construction waste diversion. This one calls out waste diversion specifically in its own category, but across the board they all address waste. This one is somewhat different. For most of the green building programs, those that I've touched upon already, they sort of come up with their own standards. They create their checklist based on, a list of standards that are generated by a group of professionals and experts in the field. This one is based directly on the California Green Building Standards Code, which is an ordinance that has been adopted by the state. It's not yet a mandatory ordinance. It's only voluntary, but that is looking to change in the near future. And the standards for this one are simply that code. It makes it actually really easy and pretty simple from a building standpoint. And depending on whether or not the builder is familiar with the Green Standards Code, most builders are going to become familiar with those codes if they're not already. So it sort of just is a streamlined process in that regard. Again, a home energy rating system audit is required, and the fees are right on par with the others. Energy Star. This one applies to both homes and large commercial buildings, buildings and plants over 15,000 square feet. For homes, those two programs, homes and large buildings and plants, are completely different. They follow completely different paths. For homes, actually for all of them, each building is only really reviewed in terms of energy performance. This Energy Star program does not get into water efficiency, indoor air quality. It doesn't touch on waste. This one is energy specific. It requires that the buildings perform at least 15% better than the 2004 International Resource Code. Again, the paperwork in this case can be completed either by the occupant or the building manager, and this one has a really simple online tool that you can use to sort of compare your building against other buildings of its type. HERS audit is required for the home. For commercial buildings, a commissioning process is required. An engineer must come in and commission the building. And the fee, it's free to enroll, but again, that inspection, $800 to $1,200 for the home audit, and commissioning usually is quite a bit more expensive depending on the size of your commercial building. Just a few more. These are moving on to only commercial buildings. LEED, again, they have a very large suite of resources and standards that apply to new and existing commercial buildings, including schools, hospitals, commercial interiors. It's a pretty broad and wide-ranging review standard. Again, it has to be The checklist and paperwork must be completed by a lead professional. The builder, the occupant, bringing everyone into the lead process at the beginning is best. For the commercial buildings, it does require commissioning, and the fees really vary depending on the size of the building and the type of the building. $600 flat fee to enroll, and then anywhere from $1,500 up towards $30,000 for a commercial building to become LEED certified. Can be rather expensive for commercial. And last, Green Globes. Green Globes started in Canada and has been slowly trickling into the United States, but once the U.S. Green Building Council launched LEED, it sort of wiped out the Green Globes reach in the U.S. It's operated by the Green Building Institute. It applies to new and existing commercial buildings. It's got the typical list of categories under which to gain points. Again, this one is completed by the builder and the occupants, and it's a nice online program that provides a lot of easy-to-access online resources for both the building occupant and the builder. A third-party assessment is required, and the fees are anywhere between around $5,000 to $7,000, and the party going after the certification must also pay for the travel for the assessor to come and visit you and assess the performance of the building. That wraps up my presentation, and I'd be happy to answer or try to answer any of your questions.
Hi. You described that there were fees involved in the LEED commercial building and LEED home monitoring processes, but my understanding is there's also associated costs along the way that beyond enrolling your project and having your project tested. Can you help describe some of those other costs? And I don't mean to include the cost to the actual board and nail cost of using materials that qualify, but other administrative costs, such as someone who has to possibly come on in some more complicated projects, we have to hire a staff member to handle the paperwork and some of the other aspects.
Well, under the LEED program, whether it applies to homes or commercial buildings, you get an extra point for having a LEED associated professional associated with the project. So to address your comment of bringing on an extra staff person, if you're working with an architect or a builder who doesn't already have a LEED associated professional on staff, and you want that extra point to count towards your overall rating, hiring a LEED AP is one option to do that. Hiring a LEED associated consultant would be another one, and so there would be fees associated with that as well. For the LEED for Homes project, there are LEED for Homes providers. The way the national organization has set up the homes program is they provide raters to different regions of the country. Here in our region, it's Davis Energy Group, and so I'm not completely familiar with the fees associated with Davis Energy Group, but they shouldn't be too far above the inspection fees and the enrollment and administration fees that were listed. But there may be some additional ones.
Okay, we're a little behind schedule, so.
Okay, just one last comment. The flyer that everyone should have a handle on, that is getting turned into a much more user-friendly and pretty brochure at the Community Environmental Council. It'll be called Get Started with Green Building. Our webpage is at the bottom, so please check back in a week or two, and that will be available to you for download. Yeah, LEED certified homes have, or any green building, green certified homes have shown to sell more on an open market and rent more. Absolutely.
Do you want to put up the next PowerPoint? Or? Okay, so Michelle's going to set up the next PowerPoint, and just you can see in this packet here is the one that I'm doing. Our current regulations regarding green building is the second page there. Right now we have basically an expedited program for anybody who does the Built Green 2-star level or an equivalent program at that level. So that if it's a voluntary situation, so you can submit, and then your plans would be checked ahead of other plans through the Building and Safety Encounter. Although we're also expediting the T-Fire and Jesucita Fire homes as well. So anyhow, those are the top priority projects at this time. And we also, as part of the NPO update in May 2007, Council adopted a provision whereby homes over 4,000 square feet need to have a 2-star Santa Barbara Built Green rating or an equivalent program. And so that's what I'm addressing right now is some of the feedback that we've gotten regarding that and how we're relooking at that, because Council also asked us to come back in 2 years to do a review of the Neighborhood Preservation Ordinance update. And so staff has come up with a potential alternative that would maybe be a little bit simpler than following one of the point-based programs if people would prefer to do that. Because there's really great things about the Santa Barbara Built Green program, which is why it was specifically called out in the ordinance. One is that it's locally created, reviewed, and produced, and so a lot of the local professionals here from multiple jurisdictions had input into its drafting and its updates. There's great staff that's available here locally that can help people navigate through the checklist and provide advice. It's also cost effective, especially as you saw Lindsay go through the comparisons of the other programs. It's really not expensive compared to some of the programs that are out there. It's pretty cost effective. So, however, it does involve an enrollment cost, and so that is some of the feedback that we've gotten from some of our applicants, is they would rather not have to pay an enrollment fee in any sort of a green building program if they would prefer some other method perhaps. And then we've also received feedback that yes, it is a point system, and that does take some time to navigate through that. So that's why we came up with an alternative. So our goals in this, and you'll see the list that we came up with. Now, this is just really preliminary, and we're going to take this to the Historic Landmarks Commission, the Architectural Board of Review, and then present it to Council later. So this is just kind of a heads up. We're working on this, but we don't have time for a big discussion of this today. And actually, we can't have a discussion because we do have a quorum of our single-family design board here, but I can answer just maybe a question or two about it. But there will be a lot more review on this idea. But we just basically, we want to make the ordinance really clear that you can do equivalent programs. We've also heard some people not really wanting to apply this to, say, a simple garage addition. So if we exempt projects less than 500 square feet, that should take care of that in most cases. And the set of criteria as an option is on the front part of this handout. We'll go over this. That would be a simplified green home alternative. And then some of these aspects we would have just self-certified because we only wanted things that would be easy to inspect, just really keep it simple. Or they could be something where an architect might sign off or a contractor saying, yes, it's this % of recycled materials, or we've purchased this type of thing. So we'll be implementing this later this year. So those were some of the things I was talking about as far as just our way of going about this. And I think it's actually a hidden slide in here. So we're just going to have to work off of the handout as far as the proposal itself. But let's just go ahead and go over that. We included 5 categories: site, water conservation, energy, indoor air quality, and materials efficiency. And these are similar categories as to what you'll see in the other green building programs that are out there. And so just as an example, just to keep it simple, for the category of site, you could do one of two things. One, you could either do the stormwater management program at Tier 3, or, and this is a really innovative concept here, you could do a permaculture, and there's also a program called National Wildlife Certified Backyard. And that's just a $20 fee for that one. There's a little page about that program here. They basically say you need to provide food, water, places for cover, sustainable gardening if you're going to do that one. And then the permaculture, we were thinking, just having some gardening space installed and trees or whatnot that have fruit or nuts, that would be one way. So stormwater management program Tier 3 as the first choice on the site. What that means is that you would retain and treat the calculated amount of post-construction runoff from the project site for a 1-inch 24-storm event. So you can compare that to level 2, which isn't quite as strict of a requirement. Are you familiar with the stormwater management program? Because it's a new requirement that's come out in general for the city. So most major additions will need to be complying at the Tier 2 level anyways. So if you're going to go over 4,000 square feet, and the reason why we have this requirement in the first place for the 4,000 square feet plus. Is the idea is there's some additional impacts that happen on the community having the larger types of home, and so have them give back a little bit by doing some green aspects just seemed like a reasonable thing to do, which is why it was originally included in the NPO. So then the second category would be water conservation. So just having 3 simple choices. You could plumb for gray water, use a cistern to catch the rainwater to landscape with, or just not have high water use lawn. You could have lawn alternatives that are low water use. So just picking one of 3 things versus a really long menu and adding up points and so forth. For energy, maybe just using 3 passive solar principles out of that handout that I gave you earlier from our passive solar guidelines, just demonstrating how 3 of those are used. Or you could do the Energy Star home qualification. She talked about that program. However, it does involve that inspection, and those inspections cost, close to $1,000. So that one might not be as popular, obviously, due to the cost of it. But the passive solar is pretty simple. It's just really picking out 3 out of 9 concepts and putting that into a plan set. And we didn't want to duplicate energy too much because we already have our 2030 Energy 2030 program where we require our applicants already to be 20% above Title 24, and that's going to keep increasing as the years go by. So we didn't feel like we really needed to put our applicants through, at this time we're not thinking we need to have them go through a whole nother checklist on energy in a green building program because we're already 20% above Title 24. So maybe this would be simple because Title 24 doesn't really emphasize passive solar a whole bunch, and so this might be an opportunity for that through this program. Indoor air quality, we just thought keep it simple again, maybe no VOC paints, or the Built Green program offers 10 points. If there's no carpet, that's a pretty high point item, so we thought, okay, we could pick doing those 2 perhaps. And then for the last one, materials efficiency, 90% demo and construction waste to be recycled or reused. That's in our Planning Commission conditions of approval that are somewhat standard now, so it would just be following something that would be a PC approval item anyhow. The larger homes used to go to Planning Commission. They don't now because of the new NPO so often, but another option then would be instead buying recycled materials in the construction for use. So those are the basic concepts, and I'm taking up my time here. So any just quick questions before moving on?
Review and then adoption process, and do you have a timeline in mind?
Yeah, so we don't have a date yet for going to ABR, HLC, because those are the 2 review boards that look at single-family homes now. Excuse me, not ABR. I keep saying ABR. Single-family design board, and HLC is where we'll be going with this one because ABR doesn't look at the single-family so much anymore, just the leftovers from before the NPO. But it'll be hearings at those boards, and then we're having an NPO workshop actually within probably the next month or so. That'll probably be like on a Saturday where all the public is invited, and so this, along with a whole bunch of other. Well, hopefully not a whole bunch. It's supposed to be a very quick, simple review, but as well as another presentation and other ideas will be looked at. And then City Council. We're supposed to be getting all this done this summer, actually, so we'll see. Hopefully it'll be coming up for pretty soon. So we'll definitely be open for lots of feedback and comments. Anybody else? Quick questions or anything like that? Dan, do you have anything you want to add about any of our presentations today? Okay, thanks.
Of introducing our next speaker, Ken Konzel with Sitka Sarnafel, and he's going to be doing a brief presentation on green roofs and cool roofs. And also just wanted to, I think everybody knows by now, but we are having an afternoon edition for an accredited training from 1:30 to 3:30, so come back after lunch and get that specialized training here. And Ken is going to be specifically talking more about green roofs and cool roofs for single-ply roofing. So with that, and we also have some handouts that Heather's going to pass around for his presentation. So we'll get
Thank you very much. And then how do I go forward? Down. Hi, everybody. My name's Ken. Thank you very much. Heather, thank you very much. And I want to thank Jaime very much for allowing us to come out and do a presentation for you. This has sort of been going on for a little bit, and we've decided from instead of doing one presentation, it got expanded to do a short presentation right now and then some expanded presentations after lunch. So what I'm going to try to do is go through our presentations like what we're going to be doing after lunch very, very briefly, and then hitting on some points talking about Title 24 and some other issues as well. Our primary product is single ply, and in this case it's actually a PVC-based product, but there's a number of products here. There's a lot of information here, and I'm just going to go right over it. If anybody's interested, we'll be going into detail a lot of this after the fact. I really want to hit the Title 24 stuff and some of the stuff that's probably more inducive of what you guys need to talk about in the green stuff. When we do talk about any type of low-sloping materials, and when we talk about low slope is 2 and 12 or less. So in most cases, it's all the stuff that you don't see on the commercial buildings that's behind the mansards and everything else. There are a number of different types of systems out there on the marketplace, traditional built-up roofing systems, mod bit systems that have worked very well and still continue to work very well. One disadvantage of a lot of the asphalt-based systems is they're black and they got to be coated to meet whatever codes that are, and obviously they're tied in with asphalt, with the cost of oil, which is going back and forth, back and forth. When it comes to polymer-based products, there's basically two types of products, and without going to a chemistry lesson, one's called a thermoset, one's called a thermoplastic. One can be welded, one can't, if anybody remembers what chemistry was like from college, which I don't. In the case of PVC, when we talk about green and everything else, there's a lot of issues that come on the table for sustainability. Obviously, one of the issues is we're talking about a product that if it goes in the landfill, it's not going anywhere. And that's one of the key things, obviously, that we're trying not to do. Other parts that come into play is carbon footprint. Other parts is what are we actually using to make these resources. In this case, polyvinyl chloride is actually 53% salt and 47% oil. We're still relying on oil quite heavily, but when it comes to salt, there's a lot of salt left and a lot of oceans that have gone away, and there's salt everywhere. So it's one thing that we could say is probably is going to be around for a while. These types of products are very lightweight, very suited for scenarios where we, are looking for. You can't have a lot of weight up on the roof. There's a natural fire resistance from the chlorine factor, colors and aesthetics, and that is also available. One important thing, and whether it's single ply or even getting a lot of coatings, what's now is becoming critical when you're looking at these different roofing systems is they are implementing reinforcements more and more. These reinforcements that are inside the product, inside the middle of these, and I'll pass some of these sheets around, and now they're even using them in coatings where they'll put a layer of coating down and put these reinforcements down. It ties the roof together better and makes a better system. We have been using a number of types of reinforcements for a couple of years, but if you're looking at any systems, make sure there's reinforcements involved. As in paint or any other types of products, everybody has their preferred formulations. Every climate is different for every type of product. A lot of people actually really think that, wow, well, in Southern California, well, we don't have a lot of wear and tear on our roofs. Well, in reality, this is one of the strongest and the worst climates for roofs in the whole country. And the issue is because we don't have rain, we have ultraviolet light all the time, and it's ultraviolet light that has the degrading properties that really tears apart a lot of roofs over time. It's important, though, when we talk about colder weather, which we really don't have to worry about here, whether a product will absorb water, its reflectivity, which we're going to get into more detail about, and then when we talk about welding. If I talk about welding, everybody here is thinking of a heat torch, or are we, in most cases on single ply, all the welding is done with a hot air gun. It's actually done 500 to 600 degrees Celsius, so there's no flame or anything else. It's done typically with just hot air. This is an example of a furniture shop in Switzerland. And I don't know about, even here in Santa Barbara, I think it wouldn't take much for somebody to want to break into this little place. But this particular building, it has this particular single ply on it for the last 40 years. Another positive attribute about good quality materials is even after 40 years, we could take and cut a hole out of that place and come back and put another patch right on top of it, so you can sustain it for as long as we need to. Examples of some vinyl roofing for, I believe that, I'm not sure if that's Toronto, but I'm not even sure if that's even there anymore. But again, an advantage of a lightweight system. A lot of flexibility in these systems. And there's an example of the heat gun that I was referring to, which we call a welding tool. And this is utilized in most all PVC and other TPOs and other products. Most of these details are actually field fabricated up on the roof so that the contractor makes sure that everything is tight. In most cases, we eliminate sealants and pitch pockets, which are the things that create the maintenance over time. And that's the idea. The less maintenance you have, the longer it's going to last. Example of details. Details are very, very important, and different manufacturers hold different criteria for warranties. And I don't care if it's built up. It doesn't matter what type of roofing it is. We have the luxury of having the Santa Anas and the Sundowners, which in most cases in our areas, the problems with roofs start at the ends where we have coping and edge metal, and the edge metal peels up and ends up taking the roof off. So it's important when you are looking at different systems, just make sure that the details on the edges are very, very strong, because that's one of your main issues. This is an example of some print work that we did for the Olympics. We were actually really excited about this. As you know, the Olympics doesn't offer much as this, and we gave them all this stuff for free if they had put our name down there, but somebody in Switzerland, where we're based from, wasn't really thinking, because we're talking about Salt Lake City in the wintertime during the Winter Olympics, and there was so much snow on the roof that nobody ever even knew that any of this existed to begin with. But it's the way it happens. Going back and touching base about LEED, and we're talking about our sustainable sites category, getting into reflectivity, which is our urban heat island effect. This was Lawrence Livermore Laboratories did a few tests a number of years ago. Phoenix was one of the areas that they did research on. Really found out that where there's a lot of black, the temperature is increased by over 10%. Well, 10% is a lot, especially when you're Phoenix and it's already 118 or 112 or whatever it is. But the other factor that involved is the higher the temperature, the more the particulates for smog come into play. So, and it happens very, very fast. So they realized very quickly, well, hey, wait a second, we can change how some of this reflectivity works and take advantage of the tops of roofs. Well, obviously, this is a great example when you talk about a big box or something where you have ability to monitor your electricity and see what savings gain there has been. There is a savings gain. That's why Title 24 was affected for the state of California, and where LEED has sort of come in and matched Title 24 rules a little bit, but Title 24 is actually even a little more stringent. There is definitely a savings on electricity, and some people think, well, and when we get into Title 24, it's what happens during the wintertime? You know, someone's going to come up with a roof that's going to be white in the summer when it's hot and black in the wintertime when it's cold, so it absorbs that heat. But the whole idea where cool roofs in Title 24 came from is we want to eliminate electricity. And so the heat really is more of a factor than the warmth, which would then, by using gas versus electricity to try to cool down. So that's why even if they consider it a conditioned space building, heated or electricity, it falls under Title 24. Cool roofs. This is basically low slope for non-residential conditioned space, is what we're talking about here. I'm not an expert on the on the residential, which I know is changing. This is going in effect August of this year. These changes came about last year. Title 24 is trying to get all the codes and everybody caught up and then basically be in effect as of August. And some of the changes are, number one, they made a slight change in zones. Zone 1 and Zone 16 is Eureka and Lake Tahoe. They decided that Eureka and Lake Tahoe, because of where they're at, weren't affected, so they're not affected by Title 24. Everywhere else is. As I spoke, we are talking about low slope, less than 2 and 12. Now there is a change here because before that's all they cared about, but now there's actually, for high slope, we're coming into play as well. One of the new standards also is saying, okay, it doesn't matter what the color is going to be when you put it on the roof, what it's going to be 3 years later. So now they've gone to an average 3 years solar reflectance, a thermal emittance of 0.075. Now, what does all that mean? I got some stuff I'm going to pass out. These are all different color membranes, and what I've actually put is R for reflectivity, E for emissivity, and SRI, which is a combination of the two terms. SRI is something that's used by LEED, where Title 24 uses these other two. Reflectivity is really what we're looking at. How much does it reflect the light back up into the sky? Emissivity is the same. Every product has an emissivity rating, either how well it holds heat in or doesn't hold heat in. So in the case of these products, so you can pass them around, they all have the exact same emissivity rating. But this also gives you a little bit of an idea of what the different colors are, from the white, which actually has an SRI of over 100, down to the dark gray, which has an SRI, solar reflectant index, of about 7. Now, all these are beyond, and we've done the test to make sure 3 years later, with standard wear and tear and dust, we still meet way beyond the values of the 0.55 and the 0.75. The other change is now we are going to steep slope. And with steep slope, where before they didn't care what color you use, now they are saying that you do have to have an solar reflectivity of 0.25 and emittance of 0.75. So that's something else that changes in August. Insulation. Insulation can be confusing, and I hear all kinds of things from all kinds of places. The bottom line, it's what the codes of Santa Barbara and how they interpret Title 24 is what they do. And different code departments interpret the rules different ways. You've never experienced that, I'm sure. For insulation, in basics, it was R12 for an area like this, and now it's going to be bumped up to R19. Areas that were based at R19 are going to be jumped up to R25. One of the main things about this, though, is the insulation has to be attached to the deck. So it could either be on the top part of the deck, or it could be below the deck attached to the deck. Everybody puts it on top of the lower panel zone. That's not acceptable by Title 24. The only thing else you can do is actually totally enclose a room and then put the insulation on top, and that would count. The other thing that you are available to go with a prescriptive approach. You can get an engineer involved and say, hey, well, we've already got this much insulation in the building. We have insulated concrete on top, and so even though we don't want the white roof, we want copper brown for it to match in, and they can do a series of calculations, and you can still be approved for Title 24, even without the white roof. But the engineer, I'm sure that complicates things a little bit. Another thing that comes up quite often is space. Well, in this case, any repair is basically 2,000 square feet or less. So if it's less than 2,000 square feet, you can do anything you need to do. If you go the prescriptive method with an engineer and you have a number of other issues relating to Title 24 in that building, you can make it so you don't need the white roof. You can, I mean, the cost of getting an engineer involved, and you have to make it up in other areas. So it's not that, you know, you have to show insulation, and you have to show, I believe you can now work in your HVAC and other aspects of it to show that you meet the standard, and they can do it. But typically it's quite costly, and usually it's a building or something that's already pre-made, and they got to figure out how to way to get there, basically. But excellent question. 2,000 square feet can be repaired, so anything less than 2,000 square feet, you can do anything you want to. It's considered repair. If it's over 2,000 square feet, then it's considered actually a roof. And from a re-roof standpoint, you can have 2 roofs up on top. Once you have 2 roofs, the roof's got to come down. You got to go back down to the deck and reapply. So, relocatable, that now falls on the same rules. And then a couple things that really doesn't affect Santa Barbara here in this case. They are now designating multi-tenant 4-story or greater, which is actually LEED designates a 4-story residential multi-use is the same thing as would be new construction. In Riverside, Redding, Fresno, Barstow, and Palm Springs now have to adhere to Title 24, which that did not have to before. And then the last thing isn't roofing at all, but it relates to us because when we deal with skylights and daylighting, now they're requiring skylights and photocell-based lighting. 8,000 square feet with a ceiling height of 15 feet. So these are things that, again, as of August, are in effect. Originally, it was supposed to be in effect in April, and then they said, but now they're saying August. Any questions on any of this? Okay, we'll keep going through this real fast. How am I doing on time? Oh, okay, good. From Title 24, going directly into LEED, we were very lucky to be able to work with UCSB on the Bren Center, which is actually a platinum project, and work with a number of aspects. For LEED, you're looking at that solar reflective index value, and you're looking at 75% of the roof must be low slope, 79, 25 for higher, oh, I'm sorry, 27 for higher slope. I got to check that number. I should know that. The other ways that it now comes into play when we're talking about LEED is when we're talking about pre-consumer and post-consumer material. Our products, these are pieces that are made during the assembly line. Of course, it gets blended right in and goes into the back of the membrane. But we're actually now even taking old PVC roofs back, grinding them up, and putting them into the back of the membrane. So that way we can keep them out of the landfills, which is one of the bigger issues. You really only have one point available to you on the white roof. If you go to a green roof, you only need 50% of the roof to be covered. And then there's a lot of other points, recycled content you can use in overburden and other stuff that I'll talk about a little later, and more my counterpart will talk about this afternoon that would give you a lot more LEED points than the 1 point from 7.2. Life cycle costing. Any system that you look at, the idea of sustainability is, hey, the longer it lasts, the better it's going to be. So by looking at systems that are in the beginning aren't going to last as long and require more maintenance, more time, versus systems that are more expensive up front that last longer. Warranties are also something else that is very important. That piece of paper never keeps the water out of the top of the roof. It's a combination of the right specification, the right contractor, and the right product that does that for you. But make sure that you check your warranties. Some have wind coverage exclusions, ponding water exclusions, things like that. Others don't. There's a lot of differences between them, and they are important. An example of a project in Wichita, Kansas, we do have a product that resembles a standing seam roof, which is sort of what this is. But the neat thing about all types of single plies is there's all ways that you can get involved in a lot of different structures where typical metal roofs and stuff doesn't come into play. So now from here I'm going to get into more about the green roofing. Is there any questions, Title 24, any of that from here back? Because this is actually a lot more interesting. Our Swiss background. We actually started back in the late 60s with tunneling through the Swiss Alps, and that's what started creating these membranes. This is a typical membrane that we use in most sod roofs. In Switzerland, there's still lots of houses just like that over there. Europe is way ahead of us when it comes to recycling and green in general. And actually, they still use goats on top of these things. I've never seen it myself, but that's what I'm told. Green roofs. it's also sort of, with everything being green these days, is sort of hard to really say. It's really a vegetated roof, and we're really trying to refer them to as vegetated roofs. Eco roofs, I've heard a little bit, but versus a green roof, we're trying to call them more vegetated roofs now. A green roof consists of growing medium, vegetated planted over a waterproofing membrane. This is what the membrane looks like, and we'll get into detail as far as drainage panels and stuff like that this afternoon, because again, this is a very shortened reference. They've been around a while. Mesopotamia is when these things started, the hanging, and Babylon. So Hanging Gardens of Babylon. So it's definitely something new, and maybe now it's coming back into a little more focus. Sod roofs, and then the ecological and aesthetic effects of a lot of these roofs, they're there. We have some challenges here in Santa Barbara that I'm going to address. I mean, we're in a desert. These things work out really well in the Northwest and other places. So there's other things we got to look at as far as being challenged. But if we're talking about green roofs in general, it's basically broken into two categories. And I don't like the semi-extensive category. It's basically extensive or intensive. And in general, extensive is 6 inches or less of overburden or more than 6 inches. And it's a difference between having very, very simple plants, sedums, we really don't like regular grasses, to be honest with you, versus actually trees or shrubs and all kinds of that stuff. Obviously, when you start doing that, there's a lot more weight involved in just the overburden soil and then drainage and actually the live load with the water in the soil itself. Example of a basic extensive green roof. Mm-hmm.
The building?
That's exactly it. It's a parapet wall that you'd be looking at, and it just falls right off the top. Now, having said this too, again, we're sort of in the desert, and we're actually working right now on some xeriscapes type of roofs, because if we want to be LEED, we got to try to make it so that we're using the plants from right here, local area, and we're trying to cut down on the water usage. So there are aspects of these types of systems, and another thing that comes into play is actually watering. There's a lot of way where you can water from the top, or we have a way that you can water from the underneath side so that you don't lose water to the environment. Typically, this is what you're looking at, though, is your vegetation, a growing medium, some sort of cloth, drainage panel, the main waterproofing sheet, and then a secondary sheet that usually sits on top of it. This is a detail of a project that's actually locally down in Hollywood, and it gets more into play of how we set some stuff out here in Southern California. One thing is we do like to initiate a drip line underneath the burden. The reason for that is twofold. Number one, we're in a desert, and so by sprinkling water from the top, you're only getting about 40, depending on the day, 40%, 60% efficiency of the water. By doing this, you're keeping the water down at the base, and we're not losing water into the environment. The other thing is it has a great tendency of keeping the moisture down low in the soil, which is what's important, because if the moisture's at the top, all the seeds and everything else that flies in from all the mountains and everything else is going to grow as weeds on the top. So in this case, it keeps the top of the soil dry so that we don't have as much weed impact on top, yet you're still getting the proper amount of water to the type of plants you use. Again, typically we like sedums. Sedums are very easy. Grasses are very tough to work with. But being in Southern California, we're really trying to come up with things, and we're working with some landscape architects on some plants that we can utilize out here that make more sense in a desert environment. Again, a cross-section, basic example of a concrete deck, membrane, drainage panel, in this case, insulation, and growth. We like to have the insulation typically down below. One thing about when our company in Boston, where all this stuff comes from, the vapor drive is opposite in Boston than it is here in California. So a lot of times when it comes to vapor barriers, we switch insulation and vapor barriers around because they don't make sense here. The other big thing is, okay, what happens when we got a leak? We got to deal with a leak. Well, one nice thing is we do have this in bright orange so that hopefully if somebody digs down, they see something like this, they realize, well, wait a second, I better stop. But we have a technology from Europe, and this is a real fancy screen. Probably came off somebody's back door, but real fancy. They take this grounding screen, and they actually put the grounding screen down below the membrane. And what we can do is using EFVM, looks to me like some fancy divining rods, but I guess it works really, really well because it takes you right to the point where water is breaking that ground and tells you exactly where there's a spot. And when we're dealing with basic roofs, it's one thing. When you start dealing with a lot of planters or intensive roof gardens and everything else, starting tearing up a lot of trees to find a leak can be very, very costly, more costly than most people want to spend. So this is one system that makes it so it's very easy to, if there is a problem, we can locate the problem and get it fixed. Green roofs and LEED. Well, there is a lot of opportunity within LEED to try to get points. Stormwater, I'm without going through all this, and this is all on your chart. The stormwater management is one way right there by stopping your flow of water. Open spaces, creating open spaces when you have like a zero lot line. Open spaces on top can go towards, I believe it's 50% of the area has to be vegetated so you can use your roof space. Recycled content in the overburden is used quite a bit. We haven't, but setting up a cistern system for your storm water and taking that storm water and turning it back into your non-potable water for your plants and everything else is another way, and there's a possibility of maybe even an ID point, innovation and design point by setting up cisterns or something along those lines. So there's a few other points. If somebody wants to make the investment in something like this, there definitely is a way to do it. Also, another thing in reference to LEED, I think one of the most important things there is you start the project as early as possible. There are so many design points that are available in the design process in the very beginning and the few projects I've been involved with, it's always taking a shell or something that's already there and trying to figure out, well, we already got this, now how do we do it? So if there's any intent on anybody that you're dealing with, they're thinking about this, start thinking the design process now, and the points are a lot less expensive than trying to change them after the fact. I think another example of both intensive and extensive in Germany. Again, in Germany, Czechoslovakia, they spent a lot of time on that. Currently, if we look at a lot of downtown places, and Chicago is definitely, this picture sort of looks like that to me, and Chicago has made it so it's now mandatory in city limits that they have to be green roofs on top. But this is what it looks like now, and we feel that this is what it could look like here in the future. So that is my abbreviated versions. If you would like very advanced versions, we're going to be spending 2 hours here this afternoon going through both of these. We'll be doing the green roof one first, and then the PVC one, single ply one second, if anybody's interested. Any questions?
What you just said about the Chicago, I thought it was just for municipal buildings.
I am under the impression that it's any new or redo building in the city limits.
Oh, so they've upped it since their initial.
That's the impression I'm under.
Oh.
I know we're working on some project out at the airport, right out O'Hare Airport as we speak as well right now. So, well, thank you very much for your